This is my report for Lab 2, lines of charge. So the purpose of this experiment was to use the data and electric field function from Lab 1 to redesign our computational model of two charged tapes, one floating above the other. Some concepts that we used in this lab were the electric field of distributed charges, in this case a uniformly charged rod. So we approximate our tape as a one-dimensional line of n point charges. And then at the end we use the summation and integration of many electric field values to estimate the overall electric field of the object. So the experimental data from Lab 1 was used to create a new model in GlowScript for the interaction of the tapes. We dropped the previous assumption that all charge was located in the center of the tape, instead assuming that the charge was evenly distributed along the length of the tape. So the same data was used from Lab 1, as you can see here. And in Lab 1, we assumed that the magnitude of the gravitational force on the top tape was the exact same as the electric force on that same tape. And we could assume this because we assumed that the net force of the y component on this tape was 0 because the tape wasn't moving. This is the visual model that I was able to produce. The top tape line of charges is represented by the red dots, and the bottom tape line of charges is represented by the blue dots. The electric field vectors produced by the bottom tape at the top tape are shown for each particle that I represented, and the overall electric force of the bottom tape on the top tape is shown in the white arrow and printed at the bottom of the screen, and the gravitational force overall on the top tape is represented by the yellow arrow and is also printed at the bottom of the screen. So I did the calculations in GlowScript and came up with a new charge. So the new charge was assigned to the top tape in order that the electric force would be equal to the gravitational force with this particular model. And each tape has charge distributed over 10 segments that I labeled DQ, and we used a for loop to calculate the overall electric field and the overall electric force on the top tape by the bottom tape at each segment labeled DQ. So from this lab we can conclude a few things. The estimated value of the excess charge increased by 5 times 10 to the negative 10 coulombs using this computational model, so it did change. The assumption that the charge distributed throughout the tape is more accurate than the previous assumption that it was all concentrated in the center. We assume that this is more accurate because it's more likely that the charge was somewhat distributed. You can see by the visual model of the charges that it resembles a tape more than just a single point charge, and so the calculations using this model were definitely more thorough and more accurate. And this model shows how the electric field radiates outward from a uniformly positively charged rod, and in this case our charged rod was a tape.